Okay, remember last week we talked about symmetry group of a square. Okay, you have a square with 4 corners, 1, 2, 3, 4. Usually, last week I showed you I put some color there and then show you how they change and rotate and they reflect, right? So this group here, symmetry group, we have a name called Theorem group. Notation is D4, right? D4. D4 Theorem group, they have, in this case, 4 rotation, 4 reflection. Okay? What happens here? D5. D5 is a symmetry group of a regular pentagon. There'll be 5 rotation, 5 reflection. Right? So for this one, D4, 4 rotation. So what can you do about rotation? You have to look at the center of the square, then you see how much I rotate, right? So rotate 90 degrees. Right? You rotate 90 degrees and see what is the consequence. Right? So these are the 4 rotation. So first one, you can see here, is a rotation of 0 degree anti-clockwise. Right? So this is 0 degree anti-clockwise. This one is what? Whatever in 1 goes to 2. So this is okay, 90 degree, row 1, 90 degree. Then the other one is 180 degree. Then 270 degree, right? So these are the rotation. Okay, you rotate the square or center, 0 degree, 1, 2, 3, 4, but still stay put. If you rotate 90 degree anti-clockwise, this corner 1 will go to corner 2. Whatever you put in corner 1 will go to corner 2. Whatever in corner 2 will go to corner 3. Right? You can see this in this 2-line form of rotation. Alright? So there are 4 rotation, and there are 4 reflection, where is mu1 and mu2. So mu1 is a reflection in the vertical line. So you reflect around here, this is called mu1. So you do a reflection around this center line, vertical center line, this is called mu1, right? And then, if you do a reflection about this horizontal line to the center, this is called mu2, if you remember, this is mu2. And then, delta 1. Delta 1 is a reflection diagonal. So reflection diagonal, this is delta 1. Okay, 2 and 4 fixed. This reflection is called delta 1. And this one is delta 2. Delta 2 and 1 and 3 fixed. So these are the 4 rotation and 4 reflection will be called last time. Then we have a Cayley table. Right? Last time we see the how to get a table, of course you can make a table for this after multiply them. Okay? So how to multiply them last week I showed you a little bit, but today we will show the time we will show a bit more. So after you multiply, you're going to get a Cayley table. Let's see how the Cayley table look like. So this is how the Cayley table will look like, where there are a little bit of arrangement. This is not the original Cayley table, but they arrange in such a way that the color looks something like this. So what they do is this. They look at a subgroup H, which is equal to row 0 and row 2. Rotation, 0 degree, and rotation 180 degree. Okay, so this is rotation group. This is a subgroup here. Then I can start looking at the cosets. What are the cosets then? Okay, the coset you can look at is okay. One of them is row 0. So everything in H multiplied with row 0 on the left side. Okay. Now row 0 is rotation 0 degree. So rotate 0 degree, rotate 0 degree, still the same as rotate 0 degree. Now roll 0, roll 2. Roll 2 is rotate 180 degree, right? Rotate 180 degree, then rotate 0 degree. Still the same as rotate 180 degree. So this is roll 2 here. So this is one coset. Now I'm going to just tell you this coset is the same as another one. This is the same as multiply h by row 2. If you multiply h by row 2, you get the same coset. Okay, so rotate 0, rotate 180 degree. You will get the same set come out. Now you get the same set come out, right? Because this is rotate 180 degree. Row 2. Right? So everything you know, row 0 is rotate 0, row 2 is rotate 180 degrees. So you rotate, people ask you, rotate 180 degrees, then rotate 180 degrees. What do you rotate? How much rotate? Rotate 0 degree, no? Because when you rotate 180 degrees, then rotate another 100 degrees, you end up with, there's no rotation at all. Total you may rotate 360 degrees, right? But 360 going back to original position. As if nothing happened. Okay? So this is actually the same coset. Right? So row 0h and row 2h is the same coset, right? Now let's try another coset. Which is easy to understand one. Row 1h is everything in h multiplied by row 1 on the left side. So what do you think this is? Okay, row 0 is rotate 0 degree, followed by rotate 90 degree. So what is the end result? Rotate 0 degree, rotate 90 degree, and up is the same as rotate 90 degree. Now, if you rotate 180 degree, followed by rotate 90 degree. How much do you rotate altogether? Rotate 270 degree. Right? 180 there, another 90, altogether 270. Right? You rotate 180, then rotate another 90, the total rotate 270, which is row 3. Row 3 is rotate 270 degree. Now this is the same as row 3 times h also. Check, do you agree or not? Okay, row 3 times h. If people ask you, rotate 180 degree, then rotate 270 degree, how much will you rotate? Okay, they rotate 180 degree, row 2 first, rotate 180, and rotate and half, 270. How much should I rotate? We just say 180 plus 270, then minus 360, right? You can tell how much you get. The same rotation of 90 degree. Okay? So, this coset row 1h and row 3h are the same coset. So how many cosets I have now? I show you 4 cosets already now. Oh, this 4 cosets. These two are the same. Row 1h and row 3h are the same. Row 0h and row 2h are the same. Oh, this 4 cosets. Total, how many cosets can you get? This D4 has altogether 8 elements. I can see that. Row 0, row 2, row 1, row 3. Row 1, row 2, delta 1, delta 2, right? Altogether 8 elements. So the most you get 8 cosets. Right? But not all the cosets are different, just as I showed you earlier. So let's try to figure out what is the coset of mu1h. Okay? So let's do a little bit of calculation. I want to find the coset mu1h. Okay, so okay, I'm going to find out what is mu1h. A little bit of revision.